HP's multi-jet fusion technology promises to take 3D printing into a true production process. I'm with David Tucker. He's market development engineer with HP 3D. And David, 3D printing, of course, has been around for a couple of decades now. Historically, it's a prototyping process, but if you're an injection molding mass production professional, you wouldn't historically look at this technology. You got something here that could actually be a true alternative to injection molding.
Yes. So what we're looking to do is disrupt the manufacturing market by really using the strengths of our process, really a flexible building platform. And so what we've demonstrated here with this design is taking 80 individual parts, putting them inside of an array of parts, and then using AutoPack software to drive the density as high as we could. Then we thought, how do we actually use design to optimize the density of this build? So to my left over here, we actually went through and just used design principles to increase packability, and then ran the same auto nesting software, and we're able to achieve increased densities, which we're actually able to reduce our cost per part through densification and utilize our complete build chamber.
Now, you mentioned, of course, family molds. No way you can get 80 different parts in any family mold.
Yeah.
So basically, in an environment like this, 80, you're looking at potentially, a dozen different molds replacing with one build.
Yes, exactly. The hard part about that is how do you release 80 parts with 80 different people, right? And making sure you have that communication amongst everyone, just like you would with a family mold. So as we start looking at technologies like this, that communication and collaboration between engineers becomes ever more important.
Now, you mentioned some anisotropic properties in here. The build is not dimensionally as precise in every dimension. I think Z-axis you mentioned, is the one which you want to walk. So do you stack the parts differently? Do you fill the build envelope differently, knowing that?
So knowing that we like to empower engineers with the anisotropic effects that you would see from the process, and then try to use those effects as strengths. Since we're a layer-to-layer process, having a thicker layer actually promotes speed, right? So being able to optimize for those processes really is leveraging what you really need for the part, and then how do you maximize throughput.
Now, of course, injection molding draft angle is critical, because you've got to eject the part from the mold.
Yeah.
Is that still a factor here? Do you still worry about that, or can you basically build in undercuts and features that aren't possible the other way?
You can build a lot of features that aren't possible, but we still like to think about draft angles because we like to promote stackability. Like for these parts, for instance, we've added a simple draft angle to the sides of them, improving densification and therefore driving down economics and allowing us to compete against traditional manufacturing technologies like injection molding.
Can a part designer comfortable with injection molding technology transition to this technology and still be comfortable designing parts?
Think about how you're designing those parts and looking at how you're integrating parts together, and maybe get rid of some of the traditional consistent wall stock. We don't necessarily need that rule, and that's probably the most important rule of injection molding, but that doesn't necessarily apply to us in HP 3D printing. So they'd want to think about that, but definitely the people can transition and learn the new principles.
According to David Tucker, 3D printing a true production alternative to injection molding.